Okay, so the common base for this example is going to be 16 because it's in the fraction there, and if you have a 1, you can just write that as 16 to the 0. This one you could almost just do it in your head, right? But anyways, common base is 16. So for step 1, that's be the common base. Like I said, once we're done with these examples, we'll go back through and find what the common base is for each. But really, no single step in here is hard, to be honest. It's just making sure you know the steps and how to follow them. So the next step is to write each expression in terms of that base. So how would you write 1/16 as a base 16? 16 to the what power would give you 1 over 16?
Negative 16 to the negative power.
Negative
1.
Yes. So anything to the negative 1 flips the fraction. So for example, let's say we had 9 to the negative 1. That's 1 over 9. It basically just turns it into a fraction. How about on the right? How do you write 16? How do you write 1 as base 16? Anything to the... Yeah, anything to the 0 power is 1. You can write 1 as any base. It's kind of funny. You could write it as 20 to the 0 or whatever. But since we're dealing with base 16, we'll write it as 16 to the 0. So it should just look like that. Now notice, I just replaced the 1/16 with 16 to the negative 1. I kept the x, just like that. You can kind of see what the next step is going to be. In case you guys forgot, when you have a power to a power, so we have a power here, right? Then there's a power outside of that, you multiply the powers. So it's going to be negative 1 times x. If it was 16 squared to the 3rd, it'd be 2 times 3, 16 to the 6th power. And that's the whole reason we find a common base. The reason we do that is because we can turn the equation into just the exponents since the bases are the same. So just remember that's why we're doing that. It just becomes an exponential equation, meaning you just set the exponents equal to each other. So when you apply the exponent, you get negative 16 to the negative x equals 16 to the 0. And you can see now that since the bases are the same, you just set the exponents equal to each other. What do you guys think x is going to be? If negative x equals 0, what does x equal?
0.
0. Yep. Yeah, negative 0, exactly. I mean, you could divide both sides by negative 1. I'll go ahead and do that. Don't need to do it. But 0 divided by negative 1 is still 0. Yeah, but you're right. It's 0. So you should have that step written down already, but just remember step 4 is to set the exponents equal to each other because you have a common base. You have the same base on both sides. So you get x equals 0. Now the reason I said you could do this one in your head is because think about it. Only one exponent will make a number equal to 1. So it doesn't matter what this number is. It can only be one number can make that 1, and that's 0 because anything to 0 is 1. Any questions on that? Stood out to me for example 3. So when we get to example 3, it's got 2 common bases. Anyway, when you look at these two numbers, so we have 512 and we have 64, or 1 over 64, what base stands out to you?
2.
Yeah, 2. Now 8 will work because 8 cubed is 512, but most people don't know that. You can look at it and tell it's going to be base 2 based on that chart I gave you guys with the powers of 2. So either one will work. If it stands out to you, just choose that one. 2 usually works with these kinds of numbers that are multiples of 2. So common base is going to be 2. You can just write CB equals 2 or whatever. So going back to the numbers, 2 to what power gives you 512? That's why I had you guys sit there for 10 minutes and look at those. Huh? It is 9. All right, here's a good way to remember these powers. 2 to the 10th is 1024. You can work your way back from there. So if 2 to the 10th is 1024, 512 is half of that, so it must be 2 to the 9th. What about 1 over 64? Let's start with just 64. 2 to what power is 64?
6.
Good, 6. So 2 to what power is 1 over 64? Good, -6. So this is going to be replaced with 2 to the 9th. This is going to be replaced with 2 to the -6, just like this. So here again you have a power to a power. So what is 2 to the 9th to the x? What will that become?
9x.
Good, thank you. 9x. Well, going back to 1 over 64, that can be written as 2 to the -6. So now that we have the same base, we can set the exponents equal to each other. So we're going to have 9x equals -6. Just like this. So how would you solve for x from there?
Divide by 9.
Thank you. Divide by 9. And you do need to reduce the fraction. I know 6/9 reduces to 2/3, so -6 over 9 reduces to -2/3. And that's your answer.
So I feel like a lot of these are going to be fractions.
Like I said, you guys don't have to do this step. You can just go back through and check your work. It works better. But if you were to plug -2/3 back in and solve it out, it would solve out to the same thing on both sides. So it's just an option. It works with any equation. If your solution's right, then you should be able to plug it back into the original equation and it should balance, right? You could always actually use your calculator too to check it too, just by plugging it in. All right, so here we have two fractions. Like I told you guys yesterday, you kind of just want to maybe look at one of the fractions, the one that's more reduced, and figure out two different numbers that make it. So 9/4. Basically, first of all, let's just look at 9. What do you think that base is going to be?
3.
Yeah, 3, because 3 squared. 4? 2, because 2 squared. So your common base, actually I chose a different common base here. So actually that will work. I'm just looking ahead at the next slide. What else will work? What is 81 the base of?
9.
And 16?
4.
So 9 and 4 will work because there's a 9 and 4 there. Okay? You could either choose, it's funny because you could choose a lot of different things. I chose 4 over 9 just because 4 squared is 16 and 9 squared is 81. You could do 9 over 4, you could do 3 over 2, you could go 2 over 3, they all work. So I chose 4 over 9. So it looks like there's 4 different options you could choose for the common base. Actually, the 9 and the 4 will work out better than the 2 and the 3. Like, there'll be a little bit less work. All right, so here's the question. Let's look at the right first because it's easier. How do you write 16 over 81 as base 4 over 9? 4 over 9 to the what power would give you 16 over 81? Yes, second, because 4 squared is 16 and 81 is 9. How would you write 9 over 4 as base 4 over 9?
-1.
Yeah, and let me explain that for those of you who don't see that. So if you take a fraction and you raise it to the -1 power, what you're actually doing is just flipping that fraction. Okay? So for example, 4 over 7 to the -1 becomes 7 over 4, whatever. So 9 over 4 can be written as 4 over 9 to the -1 because you're just flipping the fraction. So I'm going to write that as 4 over 9 to the -1 power, and on the right 4 over 9 squared. And again, the reason we do that is because when you have a common base, you can just set the exponents equal to each other. Okay, so what is 4 over 9? What is -1 to the x power equal? How would you multiply these two?
-1.
-1x, yep. And then that's just 2. Yeah, exactly.
It's just a random
You can just write negative x or negative 1x. It doesn't matter. At the end of the day, you get the same answer. So yeah, you're right. Once you have the same base, right, they're both 4/9. That's why we find a common base. Then you can just set the exponents equal to each other. So we're going to have negative x equals 2. So x is going to be equal to what?
2.
Negative 2, because you divide both by negative 1.
That part's easy.
Yeah, that's something
It's the
I like
beginning
super
part that's
understand.
all like.
Yeah. I'm like, last part, yeah, but the beginning.